us to them. Really appreciate it. Um, I really appreciate like this group kind of started. This is like our fourth meetup at this point. And it's been really awesome to see like the group grow overall. And I know everyone has really busy schedules and busy times, but we really just want to make this like as a comfortable place to like learn and just share and learn from like one another. So a bit of like always kind of reshare these like our house rules itself. We created this community just to connect different founders and AI engineers just to learn from one another and all the different ways of how we're tackling the problems at hand. And then again, we really push these to be very discussion driven and really discussion focused. So really appreciate like the broader group's participation. And it's been really amazing to see like everyone's kind of focusing on different parts of the stack or different types of applications in AI. However, we all feel a lot of the same problems. And I think today we'll also see a lot of that. I see a lot of the themes around evals, which I know is quite a bit of a struggle. And so we're very like clear, like this is not a space to sell products. It's all just about learning to each other. It's not about pitching the company. It's about pitching the problems that we're working and the challenges we're trying to solve. And just make sure not to share anything confidential. And be thoughtful about what you present. And we want to make sure to respect everyone's time and contributions, especially the presenters. I know they put quite a bit of time and effort into the work that they're doing. Um, with that being said, today we have Delphi presenting on agent evals and how to get away with less and making it easier to do less evals to get the best output. Gamma, this like role I feel like changes every single day at this point, but like the evolving role of an AI engineer. And then lastly, with Rox AI, building research agents and running effective evals. We're actually going to go kind of opposite. We're going to start over with the Rox AI team. That's okay. Awesome. All righty. Yeah. Oh, short. Well, if I share my screen, that's the thing that I'm not 100%. So I want to make sure you have your notes. So, computer on the side. As they scroll. You okay? It's probably fine. Okay. Just normal flash works. All right. Sorry, y'all. This trouble you. Oh, it's a second tab. Okay, that's why it's too nice. Okay. Thank you. All right. Over to you, and I'll give you a number.
Right. Hi, everybody. My name is Mehul. I am on the Applied AI team at ROX. In one sentence, ROX does AI for GTM, AI agents for GTM. Um, and I'm going to start off with a little bit of context over the problem that we're trying to solve. Um, so this is what the ROX platform today looks like. And as you can see on the left, we have a bunch of accounts. This one is a rather short one, rather short list. There's 19 accounts in here, but we have users, their account lists go up to thousands. And the problem that I particularly work on is given these lists of thousands of accounts, we want to do batch research and ask questions like, who are these people's competitors? What are their team initiatives? What is the company? What is the company discussed? Company size and stuff like that. So I'm going to start off with a little bit of context. So the problem space that I work on is we want to design a system to do batch research using various data sources, web, CRM data, emails, along those lines. And we want to do it in such a way that it is at scale. We do around 10 million agent runs a week, and we're growing fast, which is at high performance, which means we deliver good quality outputs to the people doing research. It is at low latency, because you can imagine that if someone tries to initiate some research, they want to see outputs fairly quickly, and we want this to be able to happen in multiple modes. Like research today on the Rocks platform happens in two ways: user initiated and background refreshes. And so this is sort of the lay of the land of the problem space that we're working with. And the way I'm going to structure this is I'm going to present a few challenges that we faced while building solutions to this. I'm going to pose a few questions to the group. I would love all of your inputs on, things that you've tried, what has worked, what has not worked, challenges that you've faced, similar, what use cases you've seen, things along those lines. And then after we discuss along those lines, I'll go and tell you how Rocks solves these problems today. All right. First topic is designing for scale. I think a lot of us in the room know that there's a trade-off between latency and performance. If you have a stronger model, a GPT 5.2, that will typically take longer to solve a problem than a GPT 4.1 will, but it'll typically have a better performance and a higher quality output. The second theme here is cost optimization. At 10 million runs a week, we need better alternatives than throwing frontier models at every single run. How do we do this while maintaining performance? And three, as I mentioned earlier, we currently run our research agents in two modes. There's user-initiated and there's background agents. How do you systemize an agent that can be run in multiple modes? So I'd love to open the discussion to the room. Off any of these three topics, what have you seen? What have you tried? What has worked? What has not? Yeah, please.
It depends on the application.
Yeah, totally fair.
So this is latency versus performance.
Yeah.
So we're working on something that's related to AI/BI.
Yeah.
Financial data.
Sure.
In that case, yes, latency matters, but I do need to ensure that I'm using a performance model to be able to give. Oh, yeah. In that case, like I need a performance model to ensure that there's accuracy in the results that we're producing.
Very fair.
So we play the game of streaming to deal with latency. Sorry, I got excited. So yeah, that's one of the examples that I.
Awesome.
Yeah.
I'm very
Yeah.
curious. How do people react to streaming? Like, have you seen any interesting user takeaways of like how they interact with the streamed response versus the batch response?
Yeah, there was a little bit of training from our end that we had to do. They do like the streaming response. I mean, once we explained why this is happening,
Yeah.
then they were like, oh, yeah, that makes sense because now my end user is not going to wait or I'm tricking them
Right.
into waiting. So,
Awesome.
Yeah.
Very cool.
Yeah.
Thank you for sharing. Oh,
Like, are you sure that your performance would decrease if you tried a smaller model? Like we have a bunch of tasks in our flavor which just aren't that hard. Like
sure.
like we like to think that they're pretty hard, but actually like the weaker models are fine.
I think that is pretty fair. I mean, a concrete example here, which I can, I'll talk more about when we go to what we actually do today. But a concrete example today is if you, this happened last week. Someone was like, I want to research news events of this type, and I care only about things that happened in Canada. And so typically, like, we threw GPT 4.1 at it, and that didn't particularly do so well. Like it made up conclusions of like, hey, this thing happened in Canada, or like this person is in Canada, or whatever. And GPT 5.2 understood the user intent much better. So things along those lines. Yeah. Well, I'm curious, what kind of tasks are most prevalent in your use case?
I think something that we've noticed is that tasks that don't require long reasoning chains, like we don't need to have the powerful models do,
Fair.
like topic summarization and stuff like that. Like
Very fair. Also, if you don't mind me asking, what is the product/use case that you're
oh,
using?
it's like a data science platform.
Got it.
But some of like the background tasks are
Awesome.
easier, more straightforward.
Makes sense. All right. Okay, we'll do one more and then we'll continue on.
Yeah, it's funny, Mike, but yeah, I think one thing that we've started noticing is that if you do KV caching correctly, then a lot of the performance considerations go away. And especially if you're doing more like labeling type tasks, then what ends up happening is that your prompt, the policy ends up being really, really long, right? And then the actual data, the dynamic part is pretty short. And also like I think there's a pattern now of like folks doing more sub-agents. And sub-agents, the beauty of it is that you control kind of the upfront prompt, the policy of the sub-agent. And so it doesn't inherit all the dynamism of all the reasoning chains that come before. And so I think there's like ways around some of these problems if you do KV caching smartly, but that will take a little bit more optimization. I think most folks today have been pretty happy to splash money at the problem. But I think to the previous point too, like if your agents aren't really doing much reasoning and turns out that it's a lot more like labeling tasks, then a lot of these problems can be kind of cached away almost. But yeah.
Very fair. Awesome. I don't have personal experience with KV caching too much, so I can't comment, but I'm sure there's other folks in the room that do. Very cool. All right, I'm going to go over a few things that we do today. You do need frontier models, but only sometimes, to your point, and so we route accordingly. Figure out what the user query is, route to the right model. We self-host some OSS models with comparable performance. One example here is we use GPT-5, I believe Mini or even GPT 5.1 on something versus Quen 3. We saw very similar performances. One thing that we've been playing around a lot with is breaking down complex queries. So the amount it costs to run 2 agent runs in our architecture for GPT 4.1 is less than 1 run on GPT 5.2, and we saw similar performance. So we built a system to chain these things together. It's like kind of self-hosted reasoning chains. And on the point of running it in different modes, this becomes more systems land. We have different priority queues for background versus user initiated. So we have a queue that is dedicated for user initiated actions, and that just is almost always free. Awesome. Some other things that we've tried before at previous experiments a long while ago is we cache prompts on our end, which has since been resolved. And we also tried bunching a bunch of queries into one agent run, but that led to bad quality. And so this is the trade-off game that I think a lot of us in the room are playing as well. On the UX side of things, for latency tricking, we let users preview agent outputs because we're solving for a batch of like thousands of agents. We let them see 5 or 10 outputs first, and then they have a lot more faith in the agent actually performing well. So awesome. The second big piece, the second big problem that I and this is sort of that I work on, that is stemming from the previous point, is understanding user intent. Our users will often ask us things like, were there any compelling events this week? And this is not even particularly dedicated to user personas, like the compelling events for you, for me, for Mingji, for Pranav. All of us have different compelling events that we care about. And so again, opening up the floor to the people here. If you care about this, what is your use case? And how do we figure out what a user cares about? And what approaches have worked? What hasn't? Oh, sorry, did I see a hand in the back? Have people not experimented or played around with memory? I'm very curious. Or personalization. Yeah, please.
It's not actually immediately clear to me how memory like directly affects or improves a better understanding user intent. Like I could believe that it would impact it, but it's not like the immediate solve for like we definitely encounter cases where our agent misunderstands the intent. But I don't think of memory as like the first solution that I would go to for this.
Tell me more. Like, what do you think as a solution, or I guess why does memory not address this problem? Which I do agree with, but why does memory not?
Yeah, I think for us, often at times it's just like it's more confusion about it's a lot of times it's UX confusion in our product. The example that we looked at the other day is you might ask the agent remove the background, and they actually mean to remove the background from a. So we do. I'm from Gamma. We are AI presentations, so the user might mean remove the background from the entire card, but the agent interprets as remove the background from a particular image in the card and do an image edit versus editing the card. Simple example. That doesn't seem like a memory thing for our end. And maybe it's our tasks are very low level.
Very fair.
Does your agent allow people to answer follow-up questions, or is it like single?
Currently, it is. Well, we have separate products. Research agent, not at the moment because it's very batch research.
I imagine you could just be like, okay, they just probably like, if you're confused or there's any ambiguity, just like ask follow-up questions.
Yeah. Yes. On the agent side, that does allow back and forth. 100%. That is fair. But how do you? I guess my follow-up to you. This is purely out of curiosity. How do you quantify when it doesn't understand something? Because I guess in the example of removing a background, it did understand it. It just wasn't the right thing. I don't mean to put you on the spot.
Like after the fact, you could imagine some sort of like setup that judges trajectories and like you could determine whether or not this particular trajectory exhibited signs of like needing follow-up questions. But I don't
Okay.
have any obvious way of doing
Yeah,
it.
no, I mean neither do I. I think this is an open problem. Awesome. I'll move on to the things we try. We're in very early stages of implementing memory. Memory in this instance is, and to your point, like I think that most of the failures that we see is because our agent produces outputs that are targeted more towards a different persona. And the user actually using it as a different persona. And so we're super early stages of implementing memory. I spent a lot of time thinking about this problem before I joined Rocks, and so I'm happy to chat more about it if someone's curious. But currently we do very basic, only like periodic summarizations, and we use first-hand data only. The logic there is that first-hand data is a lot higher signal than, let's say, a document somebody uploads to interpret something about them. Yeah, and if someone has implemented or played around with Anthropic's memory implementation, this is pretty much what they do as well. They do periodic summarization and consolidate if there are things that are like conflicting. We can chat more about that at some point. Third thing that a lot of us are here for is evaluating agents. Single turn LLM outputs are off to the races. You have an input, outputs, graders, but agents are still yet to be completely solved. So very broad, open question, and there's going to be follow-up later. How do you evaluate agents for a use case today? Do you evaluate? I guess, do you evaluate your agents today? Yeah, please.
Yeah, so in my project, what I've been able to do is essentially give more agents work by having them do a tournament. So they compare two different outputs produced by one model and then pick the preferential one based on the guidelines that I set. And then this keeps going until there's a winner. And then I typically use more than one judge model to get different opinions because some models are very optimistic in their scoring.
That's fascinating. What's an example of like optimistic in their scoring? Like, I guess what reasoning prompts a model to be optimistic in their scoring?
Yeah, so this is on a project that's on local LLMs. So I'm using like GLM and GPT OSS. And so GPT OSS, it's very much like, oh, 9 out of 10, 9 out of 10, 9.5 out of 10, right? Like it tends to score everything very positively. GLM is a little bit more critical. It'll score 7s out of 10s, and sometimes it'll be very, very critical. So I think it's good to kind of understand the bias of the judge model as well when trying to do this LLM-based evaluation.
There was one more hand in the behind you earlier.
Yeah, we use a combination of like judge scores, but we use like Booleans. So like it's either categorized like with yes or no for like a certain class. So correctness or like good trajectory will only let the judge pick yes or no. And then outside of that, we try to construct metrics around the structure of our agent. So one that's pretty interesting for us is like attribution, which we're able to work back from the output of the agent, like completely deterministically and say, okay, like these steps the agent took were valuable to the output versus not. And that helps us like determine, is the agent making the right choices along the way? This is more for like research tasks.
Very cool. This was going to be my follow-up question, and I'm curious if you can elaborate on this. How do you balance between the process of getting to an answer and just evaluating output quality? Or whatever design decisions went into that. I'm very curious about this topic.
Yeah, for us, we were already pretty happy with output quality, and this was in an optimization of cost. So we were more focused on the process the agent was taking because the more steps taken, the bigger the cost was. Yeah,
makes sense. Yeah.
I mean, it's not okay. It's the same AI BI thing that I'm going to talk about because in this case, our output quality is very important because it's financial analysis. But at the same time, the process also needs to be evaluated. But by doing that, and we had a process where we were actually evaluating every step. every agent action, but that was leading to latency.
Yeah.
So we have a batch way of doing the same thing. So instead of doing it for every query,
Yeah.
we're going to do it probably 10 times out of every 100 tries.
Oh, I see. I see. So you do take
Yeah.
at some point, and
It's a randomized.
I see. Very cool.
Yes.
Very cool. Yeah, that makes a lot of sense to me, actually. Awesome. I'll talk a little bit about how we do it today. We pretty much just create a sandbox and use agent traces on top of it. A sandbox is we reproduce read-only production data and at a snapshot in time. And so we try to reproduce exactly the environment that the agent had as it did in production when it was running something. Some trade-offs here are that you cannot freeze tools like web search. How do you account for that? And one sort of workaround slash I guess sidestep here is that we use logs to verify the process of using the web search results. And because you can't exactly account for, hey, here's the exact web search that happened in this particular run. So these are some things that we do. But generally forward looking, the mental model that we're going towards with evals, and this is a blog post from Anthropic that I highly recommend you check out. Is that there are a few things here where we're trying to go do multiple runs to reduce the variance of agent outputs. So it's not just one output that was really good or one output that was really bad that tanks the performance or on an eval. And the three things that we care most about is groundedness. Is given the sources, how correct was the answer based on the sources? Coverage, does this answer have the right aspects of a good answer? And high source quality, where were these sources from reputable, authoritative, whatever adjective you want to add there. So these are some general guidelines, principles, and yeah, Anthropic goes super deep into how to design this evaluation harness. And currently, we're very much in the agent harness stage of things, but this is a very fascinating problem space. Awesome. The last thing I want to talk about is scaling. The golden should be in parentheses, but scaling golden eval sets. The one problem that we face is we need a strong base of test cases to test future agent iterations on. And so I'm curious of something. What approaches have people here tried to gather high quality human feedback on agent runs? Or is your use case, is synthetic data enough for your use case? And I'm curious about like the trade-offs that people make. And how do these things change at scale? Because you can get 100, 200, however many hundred test examples, but this goes up. This becomes expensive very fast. So yeah, curious if people have thoughts here.
I think it's really tough. We just look at the data and then fix specific things a lot of the time, and that feels really bad. But it's a lot of people looking at a lot of data and then trying it over and over again.
Yeah, I will also like come forth and say this is very close to what we do. We only recently started trying to scale this a little bit. So yes, but that is the general thing that people do.
And I think if you're in an area where you don't have to do this by hand, i.e. like Facebook or Meta with their ad serving, then you're in a very special place.
First of all, I love this mic so much. Bit of a cop-out answer here, but we essentially get feedback from our users who are very upset and then pipe that into a Slack channel where all of us see it. And then the person who sees it can tag it as having any kind of issue, and that leads to it automatically getting published into an LLM ops data set with that tag. And then those tags automatically run on all of our agents periodically. So in our case at Delphi, we get very lucky when users are very upset, they want to tell us.
Yeah.
And then like that's a golden eval data set.
That's very fair.
Yeah.
Yeah. Yeah. I guess my follow-up question there was going to be how do you not every user is going to give you feedback on every run, but I guess that solves that problem.
I mean, in the case of like positive feedback, because people do sometimes use the feature to give positive feedback, we literally just throw it away. And then, yeah, I mean, like it's very easy to get happy in an AI realm, right? But also a large part of our SLA, and this goes back to your point about memory earlier as well, is that if you log in onto our platform, you have to kind of go through a few steps where you're already giving us feedback. You have to say like what you're looking for, what you liked about a certain interaction, what you didn't. Otherwise, we block your progression on the app.
I guess. Sorry.
So that's basically it. That leads to like a critical mass of like feedback that's enough for us to like bootstrap future evaluation.
I guess what I'm curious about is, wouldn't you want some positive feedback to make sure there's no regressions in your golden eval set?
Basically, just in volume, like the number of people that are saying happy things go down.
Sure.
what they actually say they like about it seems to be kind of random, which, I mean, I guess that's a good thing, right?
Interesting. Yeah. Fascinating. Okay, Delphi. I remember. Makes sense. Awesome. I have like one more slide. I'm gonna wrap up. How we do this today, we're super early. We just rolled out an in-product feedback team only to the internal team. We are in one of those lucky places where we make tools for GTM and we have an internal sales team, and they give us a lot of good feedback, mostly negative, but sometimes positive. Very, very similar. Awesome. But this is very much an open problem, and I think this will be a key to unlocking like pretty scalable agent development. Awesome. If you're thinking about any of these problems, let's chat. Please find me. If not on email, our office is across the street. And so would love to hear from you all.
Alrighty. Appreciate that. That's it still sounds like we all haven't really still figuring out and trying to crack the eval problem. We're kind of human in the loop. I'm gonna bring it over to Gamma next. Come on in, present. I'll let you go ahead and share your screen.
Cool.
Yeah. If you guys want to find
We start off by fighting off all the AI note takers. Cool. All right, so about a year ago, I was talking to a bunch of startups, and I was talking to John, my now manager here at Gamma, and I applied to Gamma to be a product manager. Then I talked to John, and he was like, you should apply to become an AI engineer. And then I was like, what is an AI engineer anyway? So fast forward 12 months later, and I still don't have any clue. So today I want to talk a little bit about how we define an AI engineering role here at Gamma, and how we organize a little bit around that. So at Gamma, we have a distinction between a software engineer on the AI team and an AI engineer. And our recruiters really love this. So I want to get back and a little bit of context on how software has changed. We started out with traditional SaaS where you have a lot of buttons, forms, and flows. Really, you have a finite set of possible actions. And your product might be very, very complicated and might be a simplification, but in theory, you have a predictable set of user paths. But then when OpenAI came along, you can see it literally on the screen, ask anything. So that means that a user can put in any text they want. And the worst is also, you have no clue what will happen after, or maybe a little bit of a clue. And now we're working towards agentic systems, and that just increases the complexity. For every box, adds this new layer of a black box. So as a result, with new AI products, we have no way of knowing in advance what users are going to put in. You have no way of knowing what the AI is going to put out. And also to untangle these user flows becomes more and more complicated. So in reality, a lot of it is just shipping it in production and improving it on the fly. So how we define an AI engineer, and to be honest, we're still exploring how all of this works. But if you think about the process of building software, we start by having an AI engineer explore what models actually can do, where it's failing, new kind of architectures. Then we create a UI prototype, and the software engineer creates this UI prototype, builds the infrastructure. This follows a more traditional software engineering pattern and then ships it. But I think when it comes to AI, there's so much more continuous improvement that needs to be done that we're now letting an AI engineer do. By the way, I'm the only AI engineer here. So if you think about the traditional software engineering process, you have a designer who creates a prototype, PM that prioritizes and balances the trade-offs. Then you have an engineer come in and create an implementation. And the engineer creates a spec to verify all the edge cases, and you have a QA team to evaluate. But after building with LLMs, after you have a product in place, the AI engineering process completely flips. So you actually start from the bottom with doing QA on real production data. Then you create some hypothesis on what is going wrong. Then you start by creating a spec on evals and like, oh, can you actually measure and verify that you're getting it wrong? Then we start by creating an implementation, and only after that we start to see on a much larger scope of, hey, what are actually the trade-offs here? If it's failing on, if one test is succeeding and it might be failing on another, what kind of trade-offs are we planning to make? So I want to give a small little anecdote on what it means to be an AI engineer. And this goes about Cloud Code. And is James still here? Yes. We started out with the release of Opus 4.5, and everyone is so excited. Oh my God, Opus 4.5 is so good. We're going to have AGI soon. But then now, real feedback to Anthropic, Cloud Code is really dumb. Isn't on a coffee break? And I find this very funny because I think about the AI engineer on the Anthropic team who like, what the hell? They have to go through this real feedback, real pain points that we all feel, but how do you even break this down? How are you going to solve for this? And similar at Gamma, I mean, everyone receives feedback where you think like, what the heck? Like, make this better. Visual storytelling should be better. Improve layouts. Okay, what do you mean? So what we do here at Gamma is we do a lot of data analysis on real user data. We spend a lot of time exploring individual traces, creating these hypotheses and failure modes. We have some local evals. To be honest, a bunch of it is just doing vibe checks. And we have a lot of users, so we have the luxury of doing a lot of A/B tests. So if someone is saying, okay, Cloud Code is dumb, what do you mean by that? How often are people saying? When are they saying this? Can you gather all the context? Then we've created this, our own, it's kind of like a glorified spreadsheet, but this is a trace viewer where we can get a feel of the messiness of real user inputs. Does the trace make sense? If you go from one step to another, what are the failure points? From there, we create some hypotheses. Oh, is it the tool call failing? Is it an orchestration issue? Is it a prompting issue? Maybe they're conflicting instructions. Then we create these small local evals to see if we can test this and see if we can improve it. And then we do a bunch of vibe checks. Again, we've built our own like a playground where we can see multiple changes at a time. And then we just do an A/B test. I feel from all the evals that we've gotten, we've tried with local evals. The most signal that we've gotten is just doing an A/B test and seeing what the real users are getting feedback for. So some things that we learned along the way, we tried first to have like an LLM judge to score on a 1 to 5, like, is the outline correct? Is the flow correct? Is it a creative thing? But we realized that it's much, much better to have very specific scenarios with clear binary outcomes. Also, to have a report of these 20 semi-reliable metrics wasn't really useful. Just ship it and get some real user feedback. Actually, every engineer loves to automate everything. So we had a hack week, and I tried to automate my own job by letting Claude run an A/B test, analyze it, make some prompt changes, but I failed. And I feel that the real reality here is we need to do a lot of manual work, digging into the data, doing local vibe checks. I don't think that's going to be a way. And then also we've engaged with a lot of different vendors, but for a lot of eval tools, this is actually the perfect use case for vibe coding. So what is an engineer actually? I think there's a difference in here where a software engineer creates this extensive test coverage, tests really rigorously before pushing to prod, thinking about all the edge cases in advance and builds the components around the model. Whereas an AI engineer is much more around digging into the data, doing vibe checks, shipping to prod and iterating quickly. and being very, very comfortable with ambiguity. And of course, the AI engineering role is shifting a lot. 2 years ago, it was all prompt engineering, hacks like, oh, take a deep breath before you continue with your assignment. AI engineers used to be product managers and lawyers and people that are very, very tactical about text. Now it's a year later, it was all about context engineering, RAG systems, context window optimization, but now everything is agents. Having all these layers of agents, sub-agents, and tool calls, you need to really be able to reason about what goes in what place and how do you balance cost, latency, and quality. So that was the end of my rant. What does AI engineering look for you? Be in the lab, yes.
Yeah, so we also had a whole bunch of discussion questions. Just go to the next slide. Kind of just want to open it up. This is like less of a technical discussion, but want to see whether this framing lands for folks. Like, I know we have companies of different sizes and maturity here, and you probably have different sort of like practices of AI engineering. Does this framing of AI software engineers versus AI engineers make sense to you? Does this land? Is this what you're seeing on your teams?
It's actually pretty interesting. We took a bit of an orthogonal approach. At Delphi, the AI engineers are kind of just the sweatiest backend engineers that are around, where essentially you're expected to be like a really, really good backend engineer to begin with really good architecture skills. But then also, to your point, you have to ship to prod very fast and iterate fast. And so you have to like demonstrate an acumen to be able to do that at scale without breaking anything. So we prescribe it a bit differently, where it's like, you're a backend engineer plus plus.
What is your product?
You can chat with a customized search engine that sounds like Arnold Schwarzenegger, and we'll say what he would say.
Any other answers to this?
Oh yeah, actually I had a follow-up. Who will decide what kind of prompt improvements to make? And how does the communication between those backend engineers and whoever decides?
So a while ago, we gave our PM access to brain trust and let her rip on prompting to see what happens. Essentially, what we found is that everybody is allowed to iterate on prompts because the data will speak for itself when it's correct. But as far as like propagating feedback that we've gotten, be it prompting related or just overall product related, that usually has to go through a few layers before it actually reaches the AI engineer. So I guess in that point, it's somehow protected from product-driven work while simultaneously being responsible for driving most of it.
So is there a lot of context loss around what the actual problem is and the traces and getting a lot more this instinct about what actually is going on here?
There was early on, for sure. Like we would essentially receive what to us looks like obfuscate feedback. And we didn't understand what the problem with how it was responding was. But I think we try to build a culture where we try to empathize with the user as much as possible. And like the AI team always sits in on like live demonstration when somebody onboards onto our product and then tries it for the first time, just so we have a really good instinct for that.
So interesting. Yeah, any other takes?
Hello. Oh wow, this is actually quite fun. Yeah, I think our setup, we're at a company called Monaco. We have a probably similar behavior pattern for AI engineers as Schwarzenegger Man. I think in that diagram you had where there was like 5 different phases or categories, and you had this like at least 1 or 2 that there was a distinction between what the AI engineer does and what a backend engineer does, or like a software engineer that does AI. I would say our AI engineers are also responsible for part of those responsibilities. So definitely like the building infrastructure bit. So they still have to do backend work, and it's both a combination of the quantitative aspects of maybe research exploration and continuous improvement, but also they need to be totally sufficient and capable of building actual the infra around it. And maybe it's a scale thing where we're like 20 engs. I don't know if that's like moderately big, where we haven't like drawn a line in the sand around the two.
Yeah, to be fair, I still do all the things across the board, so I feel the distinction is never completely narrow. But yeah, that makes a lot of sense.
I think just shout it too. I think
I have right the fun one.
I think actually like the closest thing I've seen to an AI engineer is in a previous life I was an engineer on self-driving. I think it was like probably the most similar. And before agents, it wasn't as similar, but I think now that agents are a thing, it's very similar, right? Like in self-driving, you think a lot about golden eval sets. You think a lot about like non-determinism. How do you make runs deterministic? How do you track trajectories? How do you use simulation? Like everything that we used to do in self-driving is basically coming back. But I think the key thing here is just like back in the day, we used to call ourselves like software engineer, comma, autonomy, right? I think the autonomy bit is the main thing that really makes this AI engineering and not just building regular software. Because now that you're dealing with autonomy, everyone in the org is responsible for like building these evals. We used to have these like big grids of like green and red, and every time you ship a new PR, you like check it, right? It's a very similar system, and it's just a system that has to build around this idea of like autonomy and non-determinism that really makes AI engineering, I think, different. Yeah.
Yeah, I've also heard of, I think we were interviewing a candidate who talked about how like quality engineering is now like a new role also, for at least at like these large, like Google has a quality engineering team, and it's specifically for like AI quality, but it is like kind of very similar to what you said. It's a lot of like evals, data sets, building the tooling to improve that and so forth. Yeah. I think this is actually kind of a perfect segue. This is kind of, yeah. Maybe very similar as a follow-up question to the folks who sort of treat AI engineers as like backend engineers, but with additional stuff added on. I'm actually super curious about that because when you think about hiring AI engineers, I actually feel like the profile for the backend engineer you want almost pulls in direct tension to what you, at least what we are looking for in our definition of AI engineers, which is like someone who's much more prototypey, much more like willing to just like try stuff. And I think for a lot of infrastructure folks, it's much more like, oh, I need to be very, very methodical. I need to think through like all the failure modes. But then does that sort of cut in the different direction? So general question is like, what qualities do you hire for, or do you think of when you think about the best AI engineers? And especially for the folks who have a more infra or backend leading definition. I'm curious how this question lands.
I really just wanted to talk into this again. I don't have a good answer here. No, I would say that I actually think it's like maybe a pretty natural transition that's happened in the industry over the last like 6 months to a year, where a lot of I think what is the people that have now taken on the roles of the AI engineer have actually been backend engineers in a past life or infra engineers in a past life, and the skills they've had to adapt along the process are effectively dealing with some amount of non-determinism in their systems. And so the people that we've hired that have been the best at this are the ones that have like typically been backend engineers and very strong backend engineers, infra engineers in their past lives, but they also were hacking on things with LLMs and prompting and experimenting and swapping out, open source models versus closed source models and kind of seeing the failure modes and developing intuition through sort of that practice of using things and breaking them. So yeah, I think in practice they still at their core have been backend people, but they have just learned that the new way of the world is like you can't expect 100% certainty on the things you produce. And so they have to be good at evals. So we evaluate for that. We evaluate for evals, both in the system design questions we do, have to be comfortable with tracing as a concept and prompt optimization and things of that nature. Yeah.
Any other takes?
Can someone pass
Jordan?
I just want to agree. I think what you were saying about tracing is a lot of the initial AI problems were observability problems. Like every AI product in like 2023 was trying to sell you evals and logging. Maybe still are. But I do think there's this like natural, like you need to figure out what LM is doing to optimize it, but you can't do that unless you're very good at tracing. And as systems have gotten more agentic, like it is just pretty much a true tracing problem. Like you can't just log around the issue. So I think I agree with this idea that a lot of natural crossover between the two. That's not really how it's manifested at Gamma, though.
It's making me rethink our hiring plan.
So outside, I'm gonna veer away from like what we technically screen for, and instead, in the classical sense of software engineering, there's like a definition of done and an idea that like at some point you will head bash enough and the problem will go away. For AI engineering, the thing that we're mostly screening for is just immense curiosity, where it's like the problem is just going to keep evolving and growing more heads, and that has to get you excited. If it doesn't, it's probably not a good fit.
How do you screen for that?
We ask really sweaty, hard questions.
So another way of looking at it is you're hiring for a data scientist, but with full stack skills or backend skills. That's how I hire for AI engineers.
We also have a data scientist opening, and that, our recruiters really love us.
Good for you.
Yeah. Do you have more to say about that?
I was actually more gonna say, since you said you actually originally were applying to Gamma as a product manager, I actually think that PM skills are extremely important in this age for AI engineers, right? You have to be prototyping, like you said. You have to experiment. You have to hypothesize. You have to have an empathy for users. You have to have that sort of human psychology part as well. Because talking to an LLM is almost like you're trying to brainwash the AI to be able to accomplish the goal that you think will be able to solve the problem, right? So it's like basically solving the problem, but it has to be more within like someone else said about definition of done. It's not like 100% done. It might be 70% done, and then you have to iterate to get closer to that. Which is, yeah. So I think PM skills are really important. Which brings me to the other sort of reverse question. I don't know if folks have seen this, but we at Tinyfish are now hiring more like less experienced people. So like more like fresh out of school, even like high school grads. We're seeing like they're actually super bold. They're journalists, right? They want to make change. They want to test these things and solve problems. So like I actually think that coding or technical skills is no longer like the barrier, right? Becoming a backend engineer. Now AI coding has become so good. It's more about like being the journalist and have that boldness in their approach.
Yeah, that was actually kind of a core motivation for us to kind of move in this direction of separating these roles, in the sense that I think there are just a lot of problems and a lot of like business value that can be improved without like 5+ years of traditional software experience. Where if you hire someone who is like AI native, maybe has less experience total, but is much more able to think about how to improve, do things like, oh, what should go into context, much more creative in terms of optimizing prompts, thinking about looking through all the data, things like that. It's like kind of a different profile was our thesis.
Just kind of echoing, I think, what a lot of people have been saying. I work at a bigger tech company or like mid-market enterprise, and I think engineers and PMs are kind of split into like one group is like, oh, like they're totally gonna know, like the customer's totally gonna know how to like, I don't know, fork this repo and like integrate into their workflows and blah, blah, blah. And then the other group is like, we're gonna use Gen AI to summarize the summary because that's what we want. And I think AI engineers, like the ones that are being hired at the company I work at, I think are kind of bridging that gap. So they are younger. I think they are a bit more curious and they do know like what is an agent harness? Like what are eval groups? Like do we need to create eval groups and why is that important and why should we be doing like prod data A/B testing, like those types of things. So they're very plugged into kind of what's happening in the world. And I think traditionally, or in the AI world, I should say, and traditionally like the software engineers, PMs, and kind of backend engineers, front engineers that work at, I think larger companies are not totally connected to that with relation to kind of the end user customer. So yeah.
Thanks.
I have a follow-up. Actually, I have a follow-up question actually for a lot of you guys. So like, I think it's also interesting that you guys are mentioning a lot of just like fresh out of grad, even like high school, like early that are just curious and building with these tools. I don't want to sound rude, but I know like looking around the room, some of us have been like seasoned in career or engineers or have been working in this space for some time. I don't want to sound like that, but I'm just curious of like this big emergence of AIs. It's been about 2, 3 to 4 years of this like everything's really changed of how we build and iterate. So I'm curious from like many of you because I mean the name is AI Nerd Meetup and everyone's building and working with AI in some way or form. Like, how have you seen that evolve for you as well, and like your own career and what you guys are also kind of building? Because I'm assuming most didn't start as AI engineers in this room. It was on kind of the former on software engineer. So I'm curious to see like how are you guys trying to stay sharp or evolve to become more of that AI engineer and drive like more of that curiosity.
I actually have an answer to what qualities I would be hiring for if I were hiring. I think I've been in two larger company contexts, Meta, where they actually hired PhD graduates to kind of understand the domain space of ad serving, and that was the workflow that had like qualities most similar to AI engineering, where you would kind of engineer like shortcuts to evaluating long-term ad serving growth or revenue growth, and then use that to inform your model serving decisions. And you really needed a PhD in that kind of research oriented mindset to want to continue learning more about the space and why one approach was failing and why one was succeeding. The other like context I'm in now is that more startup-y and there's more chaos, and I would actually look for like more product management side qualities, just because I think the core important thing now is to frame the problem and the product correctly so that you no longer have to solve a lot of these problems that normal AI engineering teams are running into. You can instead rely on the product itself to create that kind of data feedback loop. And suddenly, you're aligned with your mission statement. You no longer need to do all of this, like, you know, side quest to understand and fix these edge cases because the users are doing it for you.
I'm going to the question that Max posed. I've been doing, I guess, on and off like AI adjacent things for like 15 years. I think the relevant difference that I observe now, it's more in the zeitgeist. Like more people are aware, like even outside of the engineering branch that we all kind of care about the capabilities of what's possible. I think it's a lot easier to explain to stakeholders higher up, like some of the upsides, and I think more people are excited about it, and I think that's pretty cool. But a lot of the fundamental stuff that you might take more for granted if you've been doing it for a while, like having strong baselines and establishing like careful procedures and doing things like very nicely, I think. For better or worse, I've noticed that it's like less socialized. That's like a good research strategy. So I think like the enthusiasm is really high, but I think some of the fundamentals are like a little bit more by the wayside. I don't know if other people have noticed the same thing.
Yeah, maybe somewhat related. We recently started hiring for more AI engineers, and initially I thought, oh, we really got to be looking at qualities and looking for curiosity and ambiguity and yeah, good problem solving skills. But then I started to realize going through the candidates, it's been yes, it's new, but it's been a few years, and I feel everyone who is very curious about AI already has some experience. So even though that it's impossible to have like a very long chat, definitely having some experience is actually really, really helpful. Or I have yet to find candidates that I'm very excited about that don't have at least some level of experience.
I think my answer to this would have been different like a year ago, right? I feel like at this point, the top candidates probably have already made a hop to a place or at their current have found some way to get involved in building production apps with AI or have played with it and have demonstrated in a side project or something.
Yeah, maybe I'm really the prime example where I applied for a product manager. It's like, oh, I love product. I'm just gonna do that. And then my man John was like, apply for the AI engineering. I was like, But then I did the take home assignment. And I was like, oh shit, this is like a whole new way of paradigm of building product. And I really gotta get in on this. And I think just so excited about this new phase is pretty much all you need. But there's also the one thing you really need to be successful here.
All right, I know we're running low on time. Do we have one more question? I think I have one more. Let's see. Oh yeah, I think this is actually still kind of interesting. Do you embed AI engineers on product teams, or do you have them sit on their own? It sounds like for some folks, maybe this is actually they're on backend teams. I'm actually quite curious. We only have one AI engineer. There's only one of Jens, so he kind of has to do everything. And this is a question that we need to answer pretty soon. So I'm very curious from learning from you all on this.
I've actually been in two situations now where there's been like an extremely clear, obvious difference between having the AI engineers sit on their own and having them be in the product teams. And I can say pretty decisively, in my experience at least, that it works way better to have them in the product teams. Mostly because I think there's a really nice feedback loop of just being really in the loop of like, what are customers saying about this part of the product and like, what do they want? And that kind of like feeds you ideas as to like how to use AI to actually make that better. And you can like come up with ideas, improving their workflow with AI, as opposed to kind of like sitting on your own and ideating about like, oh man, like, you know, this research paper I read is really cool, but like, you know, no one actually implements this yet. And like, we'll have to do like 3 months of, you know, our own internal research before we could actually put this out. But, you know, it'll be worth it because it's really cool. I just feel like on like AI only teams, it can get a little bit navel gazy in terms of what people are focusing on. And there's a certain urgency about like developing product that kind of like forces you to really like 80/20 in terms of like what's going to make the biggest difference in what we can build with AI that's going to like really wow people, as opposed to sort of maybe a much longer loop where you kind of feel like you can take your time. I'm going on a little bit, but I think another benefit too is that like you get the resources of the software engineers in the product team. If you're like an embedded AI engineer, you can like have them help you like build the data model and build the infrastructure that's going to support the capabilities. Whereas like if you have a standalone AI team, they kind of have to build everything on their own, and they might be sort of building in a silo, trying to like slap AI on top of a product that was sort of like developed without sort of communicating with the AI people, building it in a way that would have like worked better with the AI functionality on top. And so, yeah, I'm a big fan of embedded AI engineers.
Max, are we doing on time?
Oh, I want to just say thank you.
Thank you, everyone.
Alrighty. Well, big thanks, guys. That was really great. I mean, yeah, the roles and just like hiring itself are just like ever changing. Then also when you're in the role that you think that you're in, majority of the time is really not the case itself. Delphi, let's do this. I'm excited to. I know you guys down. Unless you want to kind of here. Righty.
So ahead of time, I asked Max what the other topics were going to be, but I couldn't have imagined as good a fit as we're about to have. So my presentation today is about agent evals and specifically trying to get away with doing as little of them as possible. Or more formally, forcing convergent behavior from multi-agent systems. So evidently, we hear a lot about evals and AI and prompt engineering. That's what all of us here today are talking about. But every time we hear about this, there's a caveat attached. There's always going to be some stochasm in what happens with models. I kind of see this as a strength. What comes to mind is this picture right here. This is a toy you give to kids to explain the normal distribution, and it's called a Galton board. Essentially, it's a grid of pegs and a bunch of balls that fall between the pegs. And every ball is going to come into contact with a sequence of these pegs. At every interaction point, it's going to have the chance to go left or the chance to go right. And predicting the exact bin that a ball is going to fall in is actually very hard. But predicting the distribution of what all the balls are going to do is trivial, as is evidenced by the fact that this is a toy they give kids. So your question of like, what is an AI engineer? In my view, it's the person that draws this line on the agent system. I think as AI practitioners, it is our job to bound the forest, not the trees. So what better way to demonstrate this than an actual live experiment? Essentially, I was doom scrolling on LinkedIn and I found a paper where Axiom Labs had gotten their AI to take a math competition. The competition is called the Putnam, and it holds a dear place in my heart because it tortured myself and my uni friends. Essentially, these are 12 really hard proof-based math problems where each problem you can get a score between 0 and 10. It's given to like the 10 nerdiest math undergrad students in the country from every university, and the median score every year is a 0. And so this is an AI that they had made that essentially tries to take this exam, but more importantly, they propose a strategy for validating the reasoning steps that it takes and then checking its proof and its logic at the very end. So we're going to do this today, 6 different ways with 6 different agent architectures to sort of demonstrate this point about evals. As a prior, I know earlier I said we make search engines that sound like Arnold Schwarzenegger. Actually, we make search engines that sound exactly like you, digital living profiles. So what I've done is I've trained one on only undergraduate freely available math. And then I've armed each of the different architectures that we're going to be using with access to that API and the search tools that come with it. So specifically, our input is going to be a static math problem as just plain text. We're going to change the agent mesh that we give it to, and the output is going to be a formal proof that is then evaluated using the approach outlined in that paper. Now's the fun part. How do we design the agent mesh to maximize success while minimizing evaluation cost? Since eval cost ultimately boils down to engineering time, and that is much more expensive than any of the other resources that we'd be consuming. Right before I came up here, I actually started running it. These are 6 different architectures that are running in parallel while the talk is happening. This front end is obviously vibe coded as evidenced by the emotes and the purple everywhere. But to give you a flavor of how it works, it's proposing all of its reasoning steps, writing it as mathematical rigor, and then there's an answer checking algorithm that can find out if the proof is actually correct or not. All right. Fundamentally, there are only a few resources that we have to consider when we go through this approach. There's reasoning effort. In other words, I heard a discussion earlier about can we use a smart model in some places, a weaker model in other places. There's token spend. So for any given model, literally what is the output? But also this is tied to latency, right? If the streaming speed is slow for a given GPU, then token spend also means latency, right? By the way, it goes without saying, everything that's running here is hosted by Fireworks on GPT OSS 120B. Okay. Sometimes you're throttled by API requests or network throughput. Other times you care a lot about a lot of different callers seeking the output of your system at once. If we put ourselves in the shoes of these agents, when does it actually mess up? It either didn't have access to the data in its latent space or whatever search engine it's attached to, or it over-indexed onto the wrong thing. To try and make these agent meshes have the greatest probability of success, I kind of think the play is to make each individual constituent of the mesh have as little responsibility as possible. Make it impossible to fuck up, basically, right? But also, it should be the case that if it does mess up, that is just as much signal as if it had succeeded. So essentially, try to constrain the problem so much that the individual members that are trying to solve the problem are basically find it trivial. Kind of like a state space traversal. And if we think of this as a state space traversal, we get access to hundreds of years of tooling. Essentially, we can model all agent meshes as a Markov chain, where every state that a member of the agent mesh is in is a node, and then has a transition probability to some other state within this space. And what we really care about is what is the probability that it's going to complete a given run, it's going to get to the very end. What is the probability that it's going to get stuck, and how much time is it going to spend in this process? And basically, this is just some jargon about that. Okay, so our primitive building block, our singleton, is basically just one agent that has access to the tool calling ability of this search engine that we've indexed on all undergraduate math ever. This, I'm going to call this thing the simpleton from here on out. It's simple and a singleton, it's a simpleton. Given this primitive, this building block, can anyone think of ways that we can wrap it such that we can solve these abstract problems? Any initial thoughts that come to mind?
It should generate as output a search query for something else.
Okay, so this thing is able to do as many searches as it wants as a primitive, but like that's one unit of work. How do we compose it in such a way that it can like tackle abstract math problems?
Make a to-do list.
Make a to-do list, so planning. Okay. All right, the simplest thing we can do is just make two of them, right? One of them is an optimist, and it's trying to solve the problem outright. Another one is a pessimist. It's using the exact same tooling to fight the optimist. And you make these two battle it out until basically one of them wins. In the case of the pessimist, it only wins by surviving for a certain amount of time if you bound the problem, right? And so in this case, the probability that you get through is literally just the probability that the agent is even equipped to solve the problem. If at any point the pessimist cannot defeat an argument, it wins.
Wait, I'm confused. Isn't this like formally validated in Lean? Like, why do you need? I mean, aren't these things just like decidable?
You know if it's wrong pretty quickly, yeah. But it doesn't know what the solution is outright, and it also doesn't know. Have you? I got the sense earlier that you've taken this exam before because you laughed when I talked about it. Essentially, it doesn't know what the path to get to the solution actually is, and we've also permuted the problem such that it's not in the latent space already. And so it has to like think about what the solution, the steps it's going to take actually are, and then it can mess up by making like a logical fallacy.
Well, like, what does the output look like from one of these nodes? Or...
Yeah, lean code at the very end. You can validate that that's correct. Also, in some of them, in some variations, as you'll see, it actually produces LaTeX, and then we can validate that as well. Yeah. So in this scenario, I've plotted what happens as you raise the acceptance probability for any given state. And essentially, this is great when API calls are expensive. You have a deterministic validator, and essentially, this might take a long time to run for very complex problems, but it's pretty predictable in the number of requests that are going to happen since there's only two states that you can ever be in. Now, somebody earlier had mentioned planning, right? A different approach that we can take is that rather than having one model be responsible for solving the problem and another for challenging the beliefs that model produces, we have just one stronger model, with more reasoning allotted to it, attempting to do both things at the same time. Before I continue, can anybody think of like a problem with this approach?
I mean, you ask for an example of a problem, or
Given this architecture,
yeah,
do you see any flaws with this design?
flaws with the design. I was trying to give an example.
Sorry, could it just end up like in a rabbit hole if
Yeah.
it doesn't find the
Exactly. The
answer we
same
asked?
context has both proponents of an argument and challengers of that argument. And so if the same model was able to produce a thing that could be defeated, if its counter argument is in the same context, it can kill itself. The upside, though, is that it's less calls and it's cheaper, right? So essentially, whatever the risk, this risk factor is of getting stuck, that's the number of times that you can imagine that we're going to be in this mess. But you don't need the acceptance probability to be that much, to be very high in order to get through here. And obviously, this is much, much cheaper. Also, because you share the same context, there's less token duplication. And so this will also literally minimize costs if you're constrained by that. Then we get to one of the more exciting ones. This is a canonical multi-agent approach where you have a planner. It proposes a bunch of different strategies that may be able to clear the problem. And then it gives those to as many agents as it wants, which try to flesh out that strategy. And essentially, if any of them survive or come to a solution, we validate that solution. But also, they all share the same context, the same blackboard, such that they can learn from one another or proxy into learn from one another. In this scenario, it is definitely possible to be a bit stuck. If the planner ever decides to produce a strategy that is intractable, then any of the constituent subagents might be a fool's errand, right? So going back to the idea that the challenge that any given agent has to solve, if it fails to solve it, that has to be high signal. We've kind of failed that constraint here, right? Because it could be the case that a strategy was valid, but was actually incredibly complex. And we don't have any idea a priori if it's actually gonna pan out or not. So whatever agent is trying to solve that problem, it's completely possible that it's impossible, and it doesn't even know that and has no way of knowing that. And so this can balloon very, very quickly, but it can throw a lot of horsepower at the problem. In this case, whenever you think there are a lot of ways, whenever your user query is open to interpretation, you're more likely to find an outcome using this approach, since the objective problem is actually much, much simpler. TLDR, this kind of approach will lend itself very well to simpler input problems to begin with. And I think this goes even better back to the planning idea. It's just like the previous step, but instead there's only one strategy chosen. But now we collapse that strategy into a bunch of parallelizable subproblems and distribute those to a bunch of agents. In this case, in the event that any of the solvers actually get stuck, this is telling you that the subproblem itself is still too large. So you can do this recursively, but every time you do this, the acceptance criteria has to go up linearly. If that is the case, then this is actually bounded, will converge. Here is kind of blending the best of both worlds. The expected number of steps through here is around 3. The absorption probability is relatively high, but this is kind of expensive. The number of tokens needed to represent any given initial state multiplies as soon as it breaks down into a bunch of subproblems. That being said, you do get exponential acceptance probability as you raise the acceptance criteria of any given subproblem. And so anytime the output is complex, like solving abstract math problems, you can expect this to do relatively well. And then we can kind of just have some fun with it, right? You can make like you can do a tournament arc. You can have a bunch of them fight each other, a bunch of optimists, one pessimist. You win when an optimist kills a pessimist. And so you have n solvers. They all independently try to solve the problem. The judge evaluates the solutions. You refine off the feedback every time a given one loses. And you continue this until one of them has a fleshed out argument. When the problem is simple, this works very, very well. When the problem is complex, or when it's actually just not in the latent space, it's in balloon in cost very, very quickly. And then actually, I'm going to give you a bit of a sneak peek right now. The tournament will do very well early on. When you first start this run, it'll clear a bunch of problems very, very quickly. But at some point, it gets stuck. And when it gets stuck, it's definitely not even sure about what's happening. By the way, as a clerical point, agents can also have bad handwriting. So you asked earlier if this is like a lean checker, if this is like formalized. It's possible that it's like very, very close, but misformatted its output somehow. And if that's happening, then the feedback that's going to be given about why it's wrong, it might take it wrong. You know, just like a human can get a 0 on this exam when it doesn't really may have had a valid argument. In this case, I mean, this is a pretty grim picture, but the absorption probability is pretty high. Eventually, since we're always taking the feedback that we're given, we're either going to know that the answer is not in the latent space because we'll have traversed it completely, or we will have found it concretely while also having getting rid of any potential subproblems. This kind of isn't really feasible in production systems. It's really only good for experiments. We're just trying to do it for fun. You can see the probability of acceptance is very high very early because pretty much immediately you're killing all solutions that aren't going to work. And then there's the one that I think is like something we've all probably tried at some point. Take one agent, give it the ability to do its own chain of thought, like reasoning, give it access to a bunch of tools and let it just sit there. And like, this is constrained in our predictable cost. We know, all of us here know how to implement this. Few-shot prompting will accomplish this. And we're never really worried about like a runaway effect happening here. The cost analysis of this is pretty simple. There aren't that many states that it can go to. It can only go left to right. And the probability is just that it doesn't get stuck in any of the individual steps. And if it ever does, it has to backtrack. This will take an extreme amount of time actually to finish, even if the problem is solvable. But it'll be very, very cheap to do so. Okay. Now, before I go and look into any of the results, does anybody want to propose, given the flavor of architectures that I put forward, any potential other architectures that may have worked? All right. If we look here, I think it's been roughly 5-10 minutes that this whole thing's actually been running. The performance is pretty interesting. The hierarchical model tends to do better when it comes face to face with more complex problems, but it takes longer when posed to simpler problems. There's like a fixed cost associated. The simple generator validator circuit, unless it comes across something that it really doesn't know what to do, will actually get through a large number of problems pretty fast. And interestingly, the individual model that can pollute its own context and get stuck doesn't get very far at all. Yeah, it basically just doesn't know what to do because it has click information available. And so this is sort of like demonstrating this idea of context engineering pretty concretely, right? Where also I find this pretty hilarious. The chain of thought, it hasn't gotten anywhere yet, right? So like this is I'm gonna one-shot an agent in one line. I'm gonna give it all the tools it needs and let it just sit there. It's probably not a great idea because at this point, the number of tokens that this thing has consumed is probably larger than some that have actually solved some problems. Yeah, and the torment does pretty well. It's actually tied right now with doing hierarchical output. But generally, as the problem complexity increases, the winner tends to be the hierarchical version. Okay, that was pretty fast. But TLDR, this is just breaking down exactly all of the ways or all the times in which you can use these models and what they can get away with. I have found, or we have found at Delphi, that a hierarchical approach actually can solve the vast majority of our problems and is also kind of self-learning. Thank you. Do some discussion.
Thanks. Really fascinating presentation and approach. Curious, because the use case here was solving Putnam. How does this relate to making Arnold Schwarzenegger bots?
Oh, interesting, right? So essentially, our objective function is to pass a Turing test for anyone, right? And so this problem of like, okay, given what I know about you, what you care about, the data that you've put in, things you've interacted with on Twitter, what would you say in response to some input is just as abstract of a problem. Generally, we do this sort of stuff as legwork to know which approaches are worth pursuing and which ones aren't.
But in that problem you just described, how do you verify answers? Because here you have built-in verifiability because it's a mathematics exam, right?
Indeed, yeah, it's a little tongue-in-cheek to be using math directly, since like the whole point is that we can just check it. Usually in practice, we're working with teams of people, or these people have like actual orgs around them, and then we get real feedback from them very often. And so loosely, when they're happy, we know that it's working, but also we have examples of them in the real world speaking and giving certain inputs we can validate against.
So this is a question back at you. But, you asked us like if there's any other potential model architecture that could work in this case, what would you propose that or have thought of before that might also work that's not on the paper yet?
Yeah, so another thing here that's a bit tongue-in-cheek is that the way that we are allowing this data to get indexed is itself an instantiation of a few of these at once. And so it's possible to hybridize a few of these approaches. Primarily, I touched on earlier, you can do a recursion when you propose a sub-problem in the network approach, where here each sub-problem solver can itself decompose further. But also, you have to have a pretty good noise detector when you're doing that. You can track the information gain of all of the like outputs at every reasoning step that one of these sub-problem solvers is doing to know when you're still gaining signal or not. And so I think there's a few ways to extend this, but I also think this could benefit a bit from an adversary. Like right now, they're all optimists. I think it would be good to have like a chaos monkey in the middle, essentially just updating the shared state with any contradictions that it finds along the process.
I think that recursion piece is really important, and then also knowing when there's like a stopping factor and the criteria is really important here, because sometimes we see that a complex problem, if you keep like recursing, right, it can fall into its own map. Like, what is the stopping criteria?
Yeah, so one of the things about this approach here that maybe isn't super obvious, there's actually a feedback loop from the assembler back to the planner. And so rather than having each agent itself spawn an instantiation of these other hierarchical structures, if it ever fails, the assembler can tell the planner about why that failed. And so in parallel, you'll have like a second generation subproblem that lives in parallel to maybe one of the first generation subproblems that is aware of why it failed. And so in this way, you're kind of crossing off things to try. And if you've crossed off all the things to try,
you're either gonna run out of time, or that is your exit criteria. There's no more ideas to generate. You have to see already. All right, sounds great. We are hiring for a designer. If any of you know.
Give me 2 seconds while I pull up my screen again. Right. First off, again, big thank you to Delphi, Gamma, and Rocks presenting today. All kind of different segments, but it's still like super cool to see like how they all like complement each other like directly. So I guess just like moving forward, we already actually as of today just locked in the next meetup, and it's actually going to be across the street. Rocks AI earlier proposed and would love to kind of host. So we're shooting for like February, one of the last 2 weeks of February. So would love to have you guys there, and also again in kind of like the local area. Always again looking for different types of speakers at these meetups. I think this was a really great example of like top tier kind of quality of what we love to see kind of up during these panels itself. And then we have like a Slack channel. I'm going to make sure for like everyone who registered, you're in the Slack channel. We always want to kind of keep that activity going on there. So if there's different types of papers that you've seen that have popped up, new research that's like emerged, or even there's just, I feel like this week there's just been so many like Claudebot memes. Like feel free to send in the channel. We just want to kind of keep it. We want to keep kind of the energy and like activity going like directly there. And then open like for anyone's feedback. This is how we keep like evolving these meetups itself. We've turned to make them very much more like discussion while focusing a lot kind of on like the research and the things that we're building. But I'll be around for a little bit after, but I always love to hear from you guys of what we could do better to adapt these more. But and then lastly, I'll keep saying it, but big thank you again to Gamma for hosting today. Can't thank you enough. Love your guys' spot. That's actually one of the other fun things about these meetups. You get to see all the cool design and all the cool ways these startups are kind of building their spaces for their team. So another big thank you for allowing us in your space. Awesome. Thanks all. Live music because it sounds very, and then feel free to stay around. There's still more drinks, like and feel free to kind of connect with one another.
So funny. He's always right. Holiday thing in the design district. We did it with Parallel, Micro, and JetSpark. And one of my team members is really good friends with DJ Jake Karma. And I sat and they like got a sick DJ on holiday. We do have a contact. If you guys are in our DJ he's on our team.
That damn nightmare keeps visiting me. At the door, police. Come on. Come on. I lay here wondering if I Your ghost so relieved. These damn regrets keep eating at me. At my belief. So my midnight demons are calling me on the route from the past. My feet are aching.